So, example 2. So, given trig ratios and the quadrant of a particular rotation angle, find all other trig ratios for its corresponding reference angle. Okay? So, you're going to find the remaining ratios for these that you're missing. So, all we have right now is tan is 4/5. It tells it's in quadrant 1. Quadrant 1 is important because if you're missing the x or the y value, you need to know what quadrant it is in so that you know if it's a negative x value or a negative y value. That's why the quadrant's extremely important. So they can literally tell you just quadrant 1. Often they don't do that. Often they'll give you the restricted domain that the quadrant's in. Either way. Diagram, 4/5. So we know we have, it's in quadrant 1. And if you're drawing any of these, you're always drawing them towards the x-axis. So your triangle should make a part of like a bow tie is kind of how I say it. So if you drew the whole bow tie, it would be like this. So if it's in quadrant 1, it's going to look like the top right-hand side of the bow tie. Because you're always dealing with reference angles, and reference angles are always the value from the terminal arm to the x-axis. So that's why you get that like bow tie looking deal. Now tan, remember we have sine, your resume, tan, your Xbox, cook extra rice, sure. We need to know those things. So, what?
I just like opened my calculator and somebody wrote that.
That's creepy.
That is creepy.
Tan is y over x. So tan is y over x. So we know y is 4. We know x is 5. We use always r squared equals x squared plus y squared to get my third side. So we're missing the r. R is the radius, right, which is the same as hypotenuse. So r squared equals 5 squared plus 4 squared. R squared equals 25 plus 16, which is 41. And then when you take the square root, you take the positive or negative root 41. 41 is a prime number, so it doesn't break down. And because it's the radius, it's always what? Positive, because radius is a length. So we have root 41 here. Then I label them. R equals root 41, y equals 4, x equals 5. And then doing the trig ratios isn't too hard. So our remaining trig ratios right now, we have sine. Sine theta is y over r. So y is 4, r is root 41. What's our issue? It's on the bottom. So we have to rationalize it. I'm just going to rationalize it up here because I don't have a lot of room. 4 over root 41. So we're going to multiply by root 41 over root 41. And so you get 4 root 41 over 41. And you can multiply by root 41 over root 41 because that's just 1. Multiplying anything by 1 doesn't change anything, right? So our actual answer is 4 root 41 over 41. Then we have cosecant. Why would I do cosecant next? Because it's just the flip of sine. If I flip this one, I'm back to having a root 41 on the bottom and having issues and having to rationalize it again. So why wouldn't I just use the original and flip that? So it's root 41 over 4. Cos theta is x over r. So it's 5 over root 41, which rationalizes to 5 root 41 over 41. With cos is secant. So it would be root 41 over 5. And the only one we're missing is cotan, because cotan is the opposite of tan. So cotan theta would just be 5 over 4. If you want to do it on a separate sheet, if you can't fit it in, that's fine. Do it on a separate sheet. You try this one. What quadrant is this between 90 and 180? What quadrant is that? 2. Because this is 90, this is 180. Quadrant 2. Sine is what over what? Sign your resume. So you're looking for x. So try it out. Okay, if we want to draw it, it's in quadrant 2. We always draw towards the x-axis. I'm off. Okay, so we have y over r. Y is 3. R equals root 10. So you'd have r squared equals x squared plus y squared. And you can rearrange that because you're solving for x. So r squared minus y squared equals x squared. Root 10 squared minus 3 squared equals x squared. Root 10 squared is 10 minus 9 equals x squared. So x squared equals 1. When you square root that, you get plus or minus. So x equals plus or minus 1. Which one is it? Minus, because it's over here. Always draw it. If you sketch it out, you have a way better chance. So then we have sine already. So cosecant is just sine flipped. So root 10 over 3. Cos is x over r. So it's negative 1 over root 10. Multiply by root 10. And so it's negative 1 root 10 over 10. Secant is cos flipped. I'm going to flip it right here so that I'm not having to flip and rationalize. So it's root 10 over negative 1. But that will be written as negative root 10. They'll bring the negative 1 up. Tan is y over x. So it's going to be 3 over negative 1, or just negative 3. And then cotan is x over y, because it's just tan flipped. So it's negative 1 over 3. Now, what if I ask you for the rotational angle? What if I don't ask you for the trig ratio, but I ask you for the rotational angle? Woo, I'm wrecking stuff. Kicking things. What would I do? You have to get the reference angle first. So you have to use one of these trig ratios to find the reference angle. Reference angle, you always take the positive angle to find it. So what you would end up doing is you would secant tan 3, get your little angle in here, and subtract it from 180 to get me the rotational angle. And you did that last year, just in case you forget. Okay, let's look at question 3. Is sine theta equals negative 2/3? I move the negative up or down. It doesn't matter which one you pick it with, if it's tan or cotan. But if it's sine or cosine, your negative is going to have to go to the top. Why? What is sine? What over what? Sine is y over r. And what can't r be? Negative. So even if they had written it like this, which they often do because it makes it a little more difficult, if they had written it like this, 2 over negative 3, people will say, well, the negative's with the r. I don't care that you told me that it can't be negative. It's with the r, so it must stay with the r. No. This negative, remember I said it can move up here. It can be in front like in your question, or it can be at the bottom, right? You have to know you need to move it up here because r can't be negative. So what are they going to do? They're going to make the r negative to see if you know to move it up, right? That's how they can make the question a little more difficult. Okay. And then they make it a little more difficult by saying tan theta is greater than 0. Okay? They don't give me the quadrant. They just tell me tan theta is greater than 0. If they tell me tan or cotan or sine or cosecant or whatever is greater than 0, they've given me enough information to determine the quadrant. How? Well, let's do this. So we'll figure out what quadrant it's in by cast. Greater than 0 is a fancy way of saying what? Positive. Everyone gets stuck on that. This just means positive. So where's tan positive? In which quadrants? 1 and 3. Remember where the letter is where it's positive. So it's positive here and here. People are like, well, that gives me 2 separate answers, Lepp. I'm stuck. I can't do this question. Or they give me 2 different answers, which is not there. How can I narrow it down to which arm? Yeah. The y value in sine is negative. So it's going to have to be this one. The other way we can do it too is looking at this. This is where sine is negative, right? Where is sine negative? Here and here. Where's my doubling up arm? On this one. Okay, so we're looking at where sine is negative because our sine is negative. The only place where sine is negative when tan is positive is in quadrant 3. So it's actually indirectly telling us it's in quadrant 3. So we draw it. It's y over r, so we know y equals negative 2. It wouldn't have made sense if we drew it here, right? Because y is positive. So that's why it can't be there. And r is 3. We need to find x. Now, once I've drawn it out, people who don't draw this out, there's a big chance of them getting the signs wrong. Okay, if it's here, x equals negative. I know that right off the bat, so I'm going to put a negative there. Before I even solve for it, I know x is negative because it has to be in order to be at that spot, right? So I have r squared equals x squared plus y squared. And we're looking for x again, so x squared equals r squared minus y squared. X squared equals 3 squared minus a minus negative 2 squared. X squared equals 9 minus 4. X squared equals 5. And we square root it, plus or minus. So x equals minus or negative root 5. Because it has to be negative. Be here. Now we can do all our trig ratios. They gave us sine. The opposite sign is cosecant. So cosecant theta is 3 over negative 2. Or negative 3 over 2. Doesn't matter. Cos theta is x over r. So it's going to be root 5 over 3. Rationalized already, which is good. But when I do secant theta, it's r over x, bless you. So it's going to be 3 over root 5, which we're going to have to rationalize. So it's actually 3 root 5 over 5. How do they ask this on a diploma? They'll ask for one of them. Yeah. It's what it is. I have no idea what you're talking about. Absolutely. And then tan theta is y over x. So it's going to be negative 2 over negative root 5, which becomes positive. Why is tan positive? In this quadrant, what is tan? Positive. So that's why those cancel. Here times by root 5, times by root 5, and you get 2 root 5 over 5. And it's positive because it's tan. And then cotan is x over y. So it's negative root 5 over negative 2. which is positive root 5 over 2. And like I said, on the diploma, they'll just ask for one of the trig ratios, like cosecant or cotan or tan. You try 4. So for this one, cos is x over r. The negative has to be with the x, can't be with the r. We draw our tan is less than 0. Less than 0 means tan is negative. Using CAS rule, tan is negative in C and in S. I need to have a negative x. So which one? Quadrant 2 or 4? Do I have a negative x? 2. So this one's out. So I'm left with this one. I have x equals negative 5. I have r equals 13. And then y I need to find. And it's positive. So if I draw this out, I instantly know my sign, right? So if I had forgotten to go plus or minus on the square root when I solved for my Pythagorean theorem, it wouldn't be the end of the world. You already have the sign there. That's why drawing is very important. So we have y squared equals r squared minus x squared. Y squared equals 13 squared minus negative 5 squared. Y squared equals 169 minus 25. Y squared equals 144. Square root, and y equals 12. Plus or minus 12. There it is. It needs to be positive 12. If you get something like this on the diploma, you should be a very happy person. Not one of them is a radical. There's no rationalizing. This is like the nicest question ever they could possibly hand you, right? No rationalizing, no reducing a radical, nothing. So we have sine theta is y over r. So it's going to be 12 over 13. Cosecant theta is r over y. So 13 over 12. Cos theta they gave us. And it was negative 5 over 13. So secant theta is going to be negative 13 over 5. If you went 13 over negative 5, you wouldn't be incorrect. If you went negative 13 over 5, you wouldn't be incorrect, right? It just depends on what answer they have. Tan theta is y over x. So it's going to be 12 over negative 5. Could you go negative 12 over 5? Yes. Could you go negative 12 over 5? Yes. And then cotan theta is x over y. So negative 5 over 12. Okay, then flip over. Whenever it says exact value in trig, it's a huge hint that you're going to be using your unit circle. Sometimes you don't. Exact value means you're just reduced rational. So they're making sure that they're sort of reducing your radical, making sure that you're not turning that into a decimal. But for a lot of the time in trig, when it says exact value, it's a hint you're probably going to be pulling stuff off your unit circle. Not always, but most of the time. So this one says, what is the exact value of tan of pi over 2? Tan is what over what? Tan your x box. So it's y over x. Pi over 2 is 90. It's on your unit circle. What's your y at 90? Your y is 1. And your x is 0. What is 1 over 0? What is anything over 0? Not possible. Your calculator will say error. You can't divide by a 0. This is undefined. But you're going to find out next unit when we look at the graphs of cosine and tan graphs. You're going to find that actually there's asymptotes on tan graphs at 90s, at negative 90, positive 90, and every 180 thereafter, which you'll find out. And the reason why is they're undefined there. So you get this dashed asymptote line. Cosecant. Okay, cosecant is the opposite of what? Sine. Sine is y over r. So what's cosecant? R over y. Do we have to do all that stuff? No. What's on your unit circle? Coses and sines. X is cos. Y is sine, right? So we don't need to do that. 7 pi over 6. Is 7 pi over 6 on your unit circle? Yes. It has the point at negative root 3 over 2 and negative a half. Okay? We want sine, because if we find the sine on that unit circle, we can flip it and we have the cosecant, correct? Which of those is sine, x or y? Y. Y is sine. So at 7 pi over 6, y is negative a half. So we actually have sine of 7 pi over 6 equals negative a half. So what would cosecant of 7 pi over 6 be? Negative 2, or negative 2 over 1. Negative 2 over 1 isn't incorrect. That answer just won't be there. They'll have negative 2. Okay, so you're literally just taking, if it's sine, cosine, or sine, cosine, secant, or cosecant, you're just taking values off the edge and flipping them. Okay, if it's tan or cotan, you actually have to divide y by x or x by y. So you're going to be doing some fractions most of the time. Sine of negative 300. Can we figure out where the heck that falls on the unit circle? What's negative 300 coterminal with? Positive what? 60. So they actually want the same as sine of 60. Because remember, we just want the terminal arm, so we need coterminal, right? And we can find them. Sine of 60 is just the y at 60. What's the y at 60? Root 3 over 2. Do you see why the unit circle is extremely important to know? If not, you're going to be special triangling it till your heart's content, which is okay. It's just more work, and then you have to use cast rule as well, so you know what sign you have. It's just easier if you know your unit circle. Before we didn't press unit circle as much because in the old curriculum there wasn't as many unit circle questions, but now they're very much unit circle, like it's an outcome. You need to know your unit circle, you need to know all this stuff in the new curriculum. So it's very important to know it. So don't rebel, learn it. Okay. I didn't give it today because it's a Friday and you don't have the time to sit and go do a unit circle again, but on Monday I'll give you another blank unit circle and you will do it, and then on Tuesday, and then on Wednesday, and then forever till you're blessed with it. Okay. So it's root 3 over 2. We're done. Secant of 60. Secant goes with what? Cos. If you can't remember, you have this lovely formula sheet that says secant theta equals 1 over cos. So you know it goes with cos because your formula sheet tells you that. So let's find cos of 60 first. Cos of 60 is just the x at 60, which is a half. So what's secant 60? 2 over 1. Bless you, or 2. So you did this last year, but you didn't have reciprocal identities, which makes it a lot different. You just have to remember to flip them, that's all. Cos of 150. So go to 150, it's on your unit circle. Is it the x or the y? X, because cos is x. So cos at 150 is negative root 3 over 2. Sine of 315. Ah, 315 is a 45-degree reference angle. 45s are awesome. There's root 2 over 2, root 2 over 2. But it's in the third quadrant, so it's going to be negative, or fourth quadrant, sorry. So it's going to be negative root 2 over 2. Because it's the y, and y's are negative in the fourth quadrant. Sine of negative 30. You can either go, hey, negative 30 falls on the arm of 330 by working backwards, or you can find the coterminal. Coterminal of negative 30 is 330, same thing, right? Add 360 to it. So we're technically finding sine of 330 because it's coterminal, it ends on the same arm. Sine of 330 is what? The y value at 330, which is what? 1/2. Is it positive or negative? Negative, because we're in quadrant 4 and sine is negative in quadrant 4. Tan and cotan is where you actually have to do work. Because tan is y divided by x. Y is your y and x is your x. You're going to have to divide fractions. Okay? Unless it falls on the 90, 180, 270, or 360, because then you don't have fractions. So tan of 240. Tan is y over x. Okay? I can also write that as y divided by x. Why would I write it out sideways like that instead of above? Because it's going to be something over something divided by something over something, which just looks ridiculous. Okay? So I'm going to write it out sideways. Whenever I have fractions, I always write them out sideways, just like you did rationals, because you flip and multiply. Remember, you invert and multiply? It's way easier to invert and multiply when you have two things side by side than one thing above another. Okay? You also can't multiply when you're above the other, so it's a problem. All right. Tan of 240, we go to 240. Y is negative root 3 over 2 divided by x, which is negative a half, because you're in quadrant 3. Flip and multiply, invert and multiply the second half, not both. Just using fraction rules again. Negative root 3 over 2 times 2 over 1. The 2's cancel. And I'm left with negative root 3 over 1, or just negative root 3. If you don't believe me, you could multiply these straight across top and go negative 2 root 3 over 2, and then cross these off. It would still be the same answer. Tan of 480. 480 is a lovely number, but it's not on the unit circle directly. So what's the coterminal angle to 480? What's 480 minus 360? 120. So tan of 120. Mm-hmm. Somehow I dropped the negative off here. Yeah. It's positive. And we know it's positive too because it's tan of 240. 240 is in the third quadrant, and tan is always positive. So I should have caught myself. Tan of 480 is the same as asking for tan of 120 because 120 has a terminal arm on the same spot as 480 does, right? So that's why we can use that. 120, we're going to do y divided by x. Y is root 3 over 2 divided by x, which is negative a half, which is the same as saying root 3 over 2 times 2 over 1. 2's cancel, and I'm left with root 3. Negative. I didn't draw the negative again. And tan is negative in quadrant 2, so that's why I know my answer is negative as well. Now, especially in calculus, if you take calculus next semester and you do derivatives with trig, this 2, someone decided that other than this, we wrote like x squared, right? Or you write 2x squared or y squared, x squared, and they follow right after. For some reason, someone along the line thought trig would be really nice to have the 2 in the middle because I think it looks prettier, maybe that's why. It means this, and then people are like, I don't know how to punch this in my calculator. This little 2 in the inside, which looks nice there, I guess, is the exact same as writing this. Cos of 225 squared. I think it's just because it's easier or nicer to look at that they put the 2 in the middle. However, if you do derivatives, you're going to find out you need to do chain rule on this. You have to drop the 2 down and do some fancy stuff with it. It's way easier if you're going to write it in this form. So we will always write it in that form in calculus. Okay. This is way easier to do now. Find out cos of 225 and do what with it? Square it. That's all you're doing. That's all that little 2 does. So if I want to type cos 225 in my calculator, I'd have to type it in like this. You can't put the little squared in between the value. There's no way to type that in your calculator looking like that. Okay? You have to type it in like that. So cos of 225 is x at 225. X at 225 is negative root 2 over 2. Squared. Whenever you square a negative, it becomes positive. And when you square a square root, what happens? It goes away. So the negative squared becomes positive. You have to square every single thing when you have squared out. So negative squared is positive 1. Root 2 squared is 2. 2 squared is 4. And 2 over 4 is right, but it won't be there. A half will be there. Okay? Do you see what that square does? People, I show this and then everyone forgets when it comes to an assignment. They're like, I don't know what to do. Just write it outside, okay? Bracket it and write it outside. So those are degrees. Life is easier. These are radians. Life isn't bad, but you are going to have to find it on the unit circle in that radian measure. Or if you're stuck, what can you always do? Change it to degrees. The degree measure that lands on this is going to be the exact same terminal arm, right? So you can convert these all to degrees and find it out. It's just that you have to know how to convert. Okay? So I want you guys to try these ones. That negative 2 pi over 3, if you want to think about it, 2 pi over 3 is 120. If I reverse counterclockwise 120, I get to 240, the arm 240, and then just pull the value off of it. Sine of negative pi is the same as sine of pi. It just pops back to the same spot, which is 0. Negative 5 pi over 3 gets you 300, and 300, negative 300 bounces you up to 660. Just 60. So it wants cos half. Your homework is still on the same page as last day, section 4.3. If it says approximate values, you can just plug them into your calculator, right? What's the key thing with when you plug them into your calculator like this? Sine of 1.92. You're pressing the sine button. What do you have to make sure? It's in radian mode because this doesn't have a little degree symbol, right? I press the tan button. Oh crap, when I press the tan button, oh good, I recorded that. When I press the tan button, I press the tan button, you can put in negative 500, but it's degrees, so you have to make sure you have it in degree mode. Secant, how do you plug in secant? Write a little note to yourself here. It'd be 1 over cos 85.4 degrees. Cotan, this would be 1 over tan of 3. And your little sheet tells you that. Cotan theta equals 1 over tan of that. Like it's on there. It's on your formula sheet, right? Okay, so number 2.